Hello and welcome to Chapter 5, Operations Management, Part 1 of the Total Quality Management chapter. So now with this chapter, it basically focuses on introducing the key concepts and tools of quality, the evolution of philosophy and total quality management, or TQM, are definitely discussed. Now, quality is described through various definitions and dimensions, right? So the cost of quality are presented. The 7 most commonly used tools of quality control are presented and discussed in this chapter, along with the Baldrige Award and several certification programs are also discussed. Included in this chapter is also the contributions of several quality gurus such as Deming, Juran, Crosby, Shruhart, Feigenbaum, Ishikawa, and Taguchi. They're also represented in this chapter. And finally, the reasons for TQM failures are also presented in this chapter. Now, the definition of quality is very subjective and usually depends on the point of view of the person defining it, right? So the difficulty in defining quality, it actually exists regardless of the product, and this is true for both manufacturing and service organizations. And although there is no single universal definition of quality, some people view quality as performance to standards, while others view it as meeting the customer's needs or satisfying the customer. There are 5 common definitions that exist, so let's take a closer look at those. So now the 5 more common definitions of quality, of course, are listed here on the slide. You have the conformance to specification, which measures how well the product or service meets the targets, and tolerance. Tolerance is determined by its designers. You have the fitness for use, which focuses on how well the product performs its intended function or use. Then there's the value for price paid, and this is basically a definition of quality that consumers often use for product or service usefulness. This is the only definition that actually combines economics with consumer criteria, simply because it assumes that the definition of quality is price sensitive, right? And if you've had your economics class already, then you understand the importance in economics of consumer choice and scarcity, right? As well as opportunity costs. You also on this list have support services, which provides it's often provided are often how the quality of a product or service is judged, or quality does not apply to only to the product or service itself, but to the people, processes, and organizational environment associated with it. And then last but not least, you have the psychological criteria. Now this is very subjective in definition, because it focuses on the judgmental evaluation of what constitutes product or service quality, with different factors contributing to that evaluation, such as atmosphere of the environment or the perceived prestige of the product, so on and so forth. Usually quality is also defined differently as well between manufacturing and service organizations. Now, we can take a look at this slide and understand the obvious reasons why. You have tangible versus non-tangible, right? Service versus manufacturing. But manufacturing organizations produce that tangible product that actually can be seen and touched and directly measured by the customer, which denotes a focus on the product features if you're a manufacturer. Whereas if you're a service provider or service organization, you're going to produce a product that's intangible, and therefore your actual focus is going to be on some different things because there is no actual product, physical product to focus on. So the intangible nature of the service makes defining quality a little difficult because of the perceptual factors that can be highly subjective in the service industry. There is a high cost, though, to be paid for organizations or manufacturers that deliver poor quality. This cost can be divided into two subdivisions, right? You have quality control cost and quality failure cost, both of which can be further broken down into two other distinctive categories. Quality control costs have prevention costs and appraisal costs, and quality failure costs has internal failure costs and external failure costs. This figure actually shows the four categories that we just discussed and their definition. So please take a moment to either pause the video or review in your book and make sure that you're very familiar with these terms because they're important and they will come up in your business career. Now, although the conceptualization and understanding of TQM, or Total Quality Management, has changed over time, the people that have helped us understand and learn to master those concepts are legends, and they will also come up in conversation. So you may just want to be familiar with their names and what their contributions were to TQM. And while quality management focuses on identifying the causes of quality problems and correcting these problems, so by emphasizing on what the need to include every employee of the organization in the quality improvement efforts and the need to define quality based on the customer's needs, its major characteristics are customer focus, continuous improvement, quality at the source, employee empowerment, understanding quality tools, team approach, benchmarking, and managing supplier quality, and these are things that we will discuss as we continue. So now what characterizes TQM is the focus on identifying root cause of quality problems and correcting them at the source, right? So as opposed to inspecting the product after it has been made and then trying to find or locate where the error occurred and go back and make the adjustments, you're actually trying to find it while it's in the production phase or the production process. So now here we look at the specific concepts that make up the philosophy of TQM. So TQM basically focuses on customer, or the focus is on the customer first, an overriding line item that a company definitely centers on. Now here quality is defined as meeting or exceeding customer expectations. So continuous improvement is the focus on never-ending improvement, right? To understand this concept, it's important to think of improvement in terms of ebbs and flows and peaks and lows. Another word that you may hear for continuous improvement is Kaizen, and we'll discuss this more in the classroom, so please make sure you have reviewed it in your book and that you understand Kaizen and its definition. Also, take a moment to think of a company that you use on a regular basis, whether it's their product or their service. Go to their website, see if you can find any signs in whether they have posted news articles or things like that on their website. See if you can find any signs of implementing continuous improvement, whether it's through Kaizen, Six Sigma, or Plan, Do, Study, Act, or benchmarking. And all of those could be keywords for that search. But for now, let's continue on with the presentation and delve a little bit deeper into these actual terminologies. So Plan, Do, Study, Act cycle, or PDSA. It's also called the Deming wheel after its originator, and it's really actually very circular, never-ending problem-solving process or continuous improvement process. Also, another way of improving quality is by using the 7 tools of quality and control, which we'll discuss in a moment. And then you also have the quality function deployment, which is used to translate customer preferences into actual design of the product or service. So, plan, do, study, act. So now we saw on the previous slide that continuous improvement has the concept of the plan, do, study, act cycle. This cycle describes the activities a company needs to perform in order to incorporate continuous improvement in its operation. Planning is the first step in the PDSA cycle. Managers must be able to evaluate the current process and make plans based on any problems that they find. Do, of course, is the next step and suggests the implementation of the plan. Study is the third step and requires a study of the data collected in the previous phase. Now, the data is then evaluated to see whether the plan is actually achieving the goals established or not. And lastly is the act phase, right? So now during the act phase of the cycle, it just simply means we're going to act on the basis of the results of the first 3 phases. So the act phase, we're going to take all the information that we've acquired, whether it's, it's basically taking the aggregate data and breaking it down and decide what your next action step is going to be in regards to it. In TQM, the role of the employee is very different from what it was in traditional systems, right? In traditional systems, there is a very where information filters from top to bottom, right? But TQM takes a bit of a different approach where the role of the employee is and the workers are empowered. They're actually empowered to make decisions relative to quality in the production process. They are considered a vital element of the effort to achieve high quality, and their contributions are highly valued, and their suggestions are also implemented, right? So now understanding that TQM places a great deal of responsibility on all workers. If employees are to identify and correct quality problems, they need proper training. They also need to be able to understand how to access quality problems. They need proper training. They need to understand how to access quality by using a variety of quality control tools. They also need to know how to interpret those findings and how to correct problems. So now let's take a brief look at those specific tools. So now the 7 tools are the cause and effect diagrams, the flowcharts, checklists, control charts, scatter diagrams, the Pareto Analysis, and histograms. You can actually find this particular figure and diagram in your book on page 163. So make sure that you're familiar with these particular diagrams and how they look and how to read and interpret them. Now, the cause and effect diagram is called the fishbone diagram simply because, obviously, the quality problem appears or can simulate the head of the fish. You have the bone, right? And then you have the different, you have the spine, and then you have the bones that are connected to that spine. And it's basically focused on solving identified quality problem. So this, in order to use a cause and effect diagram, you actually have to have the problem already identified, and in order to solve that problem. And it's used by quality control teams and for brainstorming exercises. Then you have the flowcharts. Flowcharts are simply schematic diagrams used to document the detailed steps in a process. It's often the first step in process re-engineering. Okay. Then you have, of course, a checklist, which is a simple data checkoff sheet, right? You have control charts, which the UCL and LCL calculated limits used to show when a process is in control or out of control. For example, the weight, the width, or the volume. And we will come back to this when we go to Chapter 6, because the key tool used in statistical process control, which is what Chapter 6 is about. So we'll be coming back to a control chart. So you really want to familiarize yourself with it. Then you also have the scatter diagram, which is a graph showing how two variables are related to one another, right? So the greater degree of correlation, the more linear are the observations. That's pretty self-explanatory there. And then you have the Pareto analysis, right? Now, the Pareto analysis is a technique used to identify quality problems based on their degree of importance. Now, that's very important that you're able to understand that it is based on the degree of importance, right? So now the logic behind it is that only a few quality problems are important, whereas many others are not as critical. Now, this concept has often been called the 80-20 rule. And in TQM, it states that most quality problems are a result of only a few causes. So with the Pareto analysis, you're really honing in on what the base problems are, the significant problems, and then you're going to display the degree of importance for each element. So that's very important to understand. And last but not least, you have your histograms, and those are simply charts that show the frequency distribution of observed values of a variable. For example, service time at a bank drive-up window, or service time at just a regular fast food drive-through. It really displays whether the distribution is symmetrical, which is kind of normal, or skewed, which is abnormal, and then you would know at that point that you would need to follow up and take some next action steps in regards to it. Now, a critical aspect of building quality into a product is to ensure that the product design meets customer expectations. We've said that time and time again throughout this chapter, because the customer's expectation, the product needs to meet the customer's expectation. Now, this typically is not as easy as it seems, right? So in order to create a product that customers want, it is important to translate customers' everyday language into specific technical requirements. Now, this is where a quality function deployment tool comes in handy. Now, quality function deployment tool begins by identifying important customer requirements, numerically scoring them based on their importance, and then those scores are translated into specific product characteristics. Now, do you remember the House of Quality diagram that I went over in class and that we actually practiced as a group? Well, now you can understand the importance of that introduction and why I introduced it when I did. And here we go. Here's the beginning, how we started off with our House of Quality. And ta-da, here it is, a House of Quality diagram. So now, again, be prepared to understand how to create this diagram. This will become part of the online game that we're currently doing, so you're going to need to be able to translate the information that you're learning in this class into actual hands-on work. So now, reliability is very critical to quality. Very critical, because if your product or your service is not reliable, then you lose customer interest rather quickly. So now reliability is an important dimension of product design and function, right? The reliability of a product is a direct function of the reliability of its components parts. In other words, a product is only as reliable as what it's built out of. If you have faulty product or faulty mechanisms inside of a watch, that watch is not going to work properly and it's not going to last long. If all the parts in a product must work for the product to function, then the reliability of the system is computed as the product of the reliabilities of the individual components. For example, check out this next slide. Reliability of the system is, okay, the reliability of the system or service or product is equivalent to the reliability of the first component through the last component. In other words, as I stated previously, the reliability of that system is only as reliable as the components that it is made out of. So what do you do in a situation like that? So in order to make sure that you have reliability in your product, in your service, in your system as a whole, right, you need to increase the probability of that reliability by placing redundancies in your process system, right? By placing redundancy in your system, that is to increase reliability by placing components in parallel so that when one component fails, the other component takes over. This is redundancy to an extent. Now, do keep in mind that this is the definition of redundancy that the book has given us. Now, depending on the line of, and also as it relates to TQM, but keep in mind it could also mean different things or be used in different ways depending on which line of work or line of business that the company may be in. But it should have pretty much the same foundational definition, right? It's about placing fail-safes within the system to prevent complete operation failure. So now, everything that is said, look at the formula that's in front of you. Can you see, do you see this in the formula, everything that we've said? If not, now would be a good time to take a moment to pause the video and say the meaning of each part of the formula out loud, right? So the reliability of the system is equivalent to, or must be equal to, the reliability of the first part plus the reliability of the second times the probability of needing that second component. So now take some time. This is the end of this presentation. Like I said, we will discuss it further in class, but take some time to really think this through and make sure you have an understanding. Like I said, we will do some projects and we will discuss it further in class, and we may even do some problems as well. I will see you in class. Have a great day.